So in this assignment number 1, we are going to solve some numericals, and these are related to the precipitation values. Here we will learn how to find out the average annual rainfall using various methods. Along with that, we will also solve numericals on calculation of missing precipitation reading. Now, in order to find the average annual rainfall for a certain area, suppose if we consider any district, let us take example of Kolhapur district, then if we want to know about the average annual rainfall of Kolhapur district for today's date, in that case, we have to collect the rainfall values at various rain gauge stations in Kolhapur district. Now, these rain gauge stations are established uniformly over entire area. Where the rainfall intensity is more, there more number of stations are established. Okay, and there are some other rules for formation of rain gauge network that we will see later on. At present, you just keep in mind that to find out the average annual rainfall, a rain gauge network is established. And with the help of this rain gauge network, then it is possible to find out the missing precipitation data. It is possible to find out average precipitation over a area or over a catchment. And also it is possible to check the consistency of precipitation data. So based on point number 1 and point number 2, there is assignment number 1. And assignment number 2 is based on point number 3, that is checking consistency of precipitation data. So that is possible using one curve known as double mass curve rainfall. So at first we will see how to find the missing precipitation data. So on the screen you can see one figure. So what that figure shows? That figure shows one area. Okay, so that area is demarcated by a ridge line. Okay, the outer line is ridge line. And what is ridge line? It is explained to you during the lectures. Ridge line is a line joining points of highest elevation in that area. So that is a ridge line. So due to this ridge line, what happens? Whatever rainfall occurs in this particular area, ultimately it reaches to some common outlet. So this point is outlet. Okay, this is the outlet of this area. This area is known as catchment area. Okay, this is also known as drainage area. This is also known as watershed. This is also known as basin. So these are the parallel words for this term catchment area. Okay, so how to define this term catchment area, drainage area, watershed or basin? So we can define this term as it is a particular area separated by a ridge line from adjoining area, and the rainfall occurs in this area. Ultimately, the runoff reaches to one common outlet. So that is the definition of the term watershed, catchment area or drainage area. Okay, it is a particular area separated from adjoining area with help of ridge line. What is ridge line? It is clear to you. It is a line joining the highest elevations in that area. So due to such a topography, whatever rainfall occurs, that rainfall ultimately, that rainwater ultimately reaches to one common outlet through a network of drains. So in this network, in this figure, network of drain is shown. There is a main streamline at the center, and that main streamline is fed by a number of small streamlines. So that we can see it is a network of streamlines, or it is also called as a drainage lines. They are also recognized as a drainage lines. And all these drainage lines connected to the main drainage line, and there is a common outlet for this main drainage line. Okay, so now the concept of catchment area is clear to you. Okay, now when rainfall takes place, in order to record the rainfall, there is a need of establishment of rain gauge network. What is rain gauge network? Rain gauge network is a network consists of number of rain gauge stations. And what is rain gauge station? Rain gauge station is a place where the instrument rain gauge is placed. Okay, instrument rain gauge is placed. The instrument rain gauge is capable of measurement of rainfall at that place. These rain gauges are available in two types. One is recording type of rain gauge, other is non-recording type of rain gauge. In recording type of rain gauge, certain mechanism is provided so as to record the daily rainfall. Opposite to that, in non-recording type of rain gauge, simply the rainwater is allowed to collect in a container, and after a fixed time interval, that rainwater quantity is measured with help of measurement cylinder. So in this way, we came to know what is the rainfall at that place on a particular date. Okay, this is how the rainfall is measured. As explained earlier, this rainfall is measured in centimeter depth of water or in millimeter depth of water. It is measured in either centimeter or millimeter. Is it clear to all what is rain gauge network? It consists of number of rain gauge stations. Suppose in this area we want to know about the average precipitation. In that case, there is a need of establishment of some rain gauge stations. Okay, so these are the rain gauge stations. Let us say A, B, C, D, E, F, G. Okay, number of rain gauge station depends on what is the catchment area. Okay, what is the area of the catchment. It also depends on what is the topography of the catchment. If it is a hilly region, in that case, more number of rain gauges are required. If it is a plain terrain, in that case, less number of rain gauges are required. So in some other lecture, I will explain you how to select number of rain gauge stations for a particular area. Okay, now our target is to know about calculation of missing precipitation data and average annual rainfall. Average rainfall of the area, not annual. So it may be a daily rainfall or it may be a annual rainfall. It may be any seasonal rainfall value. So for all these types, it is possible to calculate the average rainfall value. So in order to find out this average rainfall value, this establishment of rain gauge network is necessary. And if in this rain gauge network, if some data is missing, now as I have explained that for non-recording type of rain gauges, what is essential? A manual attendant is essential. That manual attendant every day at a fixed timing collects the rainwater and it measures the rainwater in a measurement cylinder. and then he came to know what is the yesterday's rainfall, what is the rainfall for last 24 hours. So that is manually recorded in case of non-recording type of rain gauges. So suppose that manual attendant does not able to reach at that place due to heavy rain or due to some other reasons. So in that case, the data is missing for that day, for that particular station. So to find out this missing data, there are three methods. In that, the first method is arithmetic mean method. Second method is normal ratio method. Third method is inverse distance method or US weather method. Okay. So now we will discuss at first these three methods of calculation of missing precipitation data. Now, before going for these numericals, let us know about these three terms. Okay, first term is daily rainfall at rain gauge station. Now, what is daily rainfall? Daily rainfall is the amount of rainfall which is expressed in centimeter or millimeter depth of water over a period of 24 hours at a rain gauge station. Is it clear what is daily rainfall? It is the rainfall recorded for last 24 hours. Second term is annual rainfall at a rain gauge station. So what is annual rainfall at a rain gauge station? It is the sum of daily rainfall values expressed in centimeter or millimeter depth of water over a period of 365 days at a rain gauge station. See, the first value was daily rainfall value. Okay, what is rainfall in last 24 hours? So if we have a record of daily rainfall values for a year, then simply we have to add all these values. Okay, when we add all daily rainfall values for 365 days, then the resulting value, okay, its summation is nothing but it is annual rainfall at a rain gauge station. Okay, is it clear what is daily rainfall and what is annual rainfall? Now there is a term normal annual rainfall at rain gauge station. So what is normal annual rainfall? Now we know how annual rainfall value is collected. So when annual rainfall value is recorded, then such a 35 years of record is taken into account. And the normal annual rainfall value is calculated by taking the average of 35 years of annual rainfall values at that rain gauge station. Is it clear? This is how the normal annual rainfall value is worked out. So what is difference between these three values? Okay, the point of difference is only the duration for which this rainfall data is collected. For daily rainfall, the duration is 24 hours. For annual rainfall, duration is 365 days. For normal annual rainfall, duration is 35 years. Okay, so we are going to use these three terms while solving the numericals. Okay, now all of you note down these three definitions in your notebook. Okay, as our practical is for 2 hours. So you have to write down everything in your notebook. So please note down these three definitions in your notebook. Okay, now after this, let us start with the first method, that is arithmetic mean method. So in arithmetic mean method, note down the formula. The formula is Px is equal to summation of Pi upon n. So here what is Pi? Pi is summation of precipitation values at index stations, and n is number of index stations. So formula is summation of Pi upon n, where value of I varies from 1 to n. So here Px is missing rainfall at station X, n is number of index stations, and P1, P2, P3 up to Pn. These are the rainfall values at index stations in the area. So that's why this formula is written as 1 upon n into bracket P1 plus P2 plus up to Pn. So if we have to use this formula for this figure, okay, suppose at station B the data is missing. Assume that at station B data is missing and we have to calculate this Bx here. Okay, we want to know what is the precipitation value at station B. For all other stations, that is A, C, D, E, F, G, all other stations, here data is known to us, and only for B, by mistake or due to some reason, data is not recorded. So in that case, what is the formula? Formula is here Bx is equal to missing rainfall data at station B is equal to summation of Pi, that is precipitation value at station A, B for it is not known, and C, D, E, F and G. So simply we have to take average of the available precipitation values. So for taking average, we have to divide this with number of available stations values. So this is divided by n. Now in this case, what is n? This is 1, 2, 3, 4, 5 and 6. So here value of n, that is index station, is 6. And whatever the values given for A, C, D, E, F, G, we have to add all these values and we have to divide this with number of index stations. So this is arithmetic mean method. So this is a very simple method. This is a very rough method. Simply we have to take average of precipitation values at index stations. But this method is only adopted if the difference between the normal annual precipitation values at various stations are within 10% of normal precipitation at station X. Okay, again come to that figure. Let us know once again about these three definitions. So what is this PA, PC, PD, PE? All these are the daily rainfall values. If these daily rainfall values are added for 365 days, we get annual rainfall value. And when the annual rainfall values are added for 35 years, and if their average is taken, then that value is known as a normal rainfall value. So if the normal rainfall values of stations A, C, D, E, F, G are nearly equal to the normal rainfall values of station B, if difference between these two values is less than 10%, in that case only we can use this arithmetic mean method. Okay, so this is about the arithmetic mean method. So it is expected that you have to note down all these things, formulas, then meaning of various terms, and the limitation of arithmetic mean method. Also take down this last sentence which indicates the limitation. The missing precipitation Px can be determined using simple arithmetic average if the normal annual precipitation at various stations are within 10% of normal precipitation at station X. So all of you please note down this. I hope you understood this arithmetic mean method. Now based on this we will solve one problem. All of you take down this problem. This problem is on arithmetic mean method. A watershed has 4 rain gauge stations A, B, C, and D during a storm. Now here the meaning of term storm is a session of rainfall. Session of rainfall may vary from few minutes to few hours or sometimes few days. Rain gauge station A was inoperative. It is given that there are 4 rain gauge stations, and out of that one rain gauge station A was inoperative. While stations B, C, D surrounding station A recorded rainfall of 48 mm, 51 mm and 45 mm respectively. Estimate the missing storm precipitation of station A using arithmetic mean method. So here what we have to calculate, we have to find out PA. Okay, PA is required answer. So PA is required answer, and what is given? PB is given, PC is given, and PD is given. So what is the formula to find out this? Formula to find out PA is summation of PI upon N. Okay, and that is equal to summation of PI is summation of precipitation values at stations B, C, and D divided by N. What is N? N is number of index stations. Okay, that is 3. So this figure shows that this is station A, and for that PA is missing, and there are surrounding stations B, C, and D. Okay, these are the 3 stations for which values are known. From that we have to find out PA. So if we put the values in the formula, PA is equal to 48 plus 51 plus 45 upon 3, hence answer is 48 mm. Okay, so this is very simple method, but the limitation is difference between the normal annual rainfall values and normal annual rainfall value of missing station, that is station A, and normal annual rainfall values of station B, C, and D. This difference should be less than 10%. That is the limitation of arithmetic mean method. Now, when this difference is more than 10%, in that case, there are 2 more methods which provides the precise values for missing rainfall data. So it is expected that you have to note down the question and answer also. हे लिहिताय का तुम्ही सगळे?
Yes, sir.
Now let us go to the next method to calculate missing rainfall data. Next method is normal ratio method. Okay, so in this normal ratio method, the precipitation value at index station is weighted with the normal ratio. Now see the formula. What I am saying, the precipitation at index station is weighted with normal ratio. So here, suppose at station X data is missing. So formula for normal ratio is Px is equal to 1 upon n into bracket P1 into nx upon n1 plus P2 into nx upon n2 plus up to Pn nx upon nn. So this nx upon n1, nx upon n2, nx upon nn, this is called as a normal ratio. Now what is this nx and n1? So nx is, see here, its meaning is given normal annual rainfall of missing station. Okay, we have discussed three definitions. One is daily rainfall, other is annual rainfall, and third is normal annual rainfall. So what is NX? NX is normal annual rainfall of missing station. And what is N1, N2 up to NN? These are the values of normal annual rainfall of index stations. Okay, there are some index stations for which we have the daily rainfall values, that is P1, P2 up to Pn. We have normal rainfall values, that is NX, N1, N2 up to NN. So these are the normal annual rainfall values of index stations. And NX is normal annual rainfall of missing station. Is it clear? So here daily rainfall value is weighted with normal ratio P1 into Nx upon N1, P2 into Nx upon N2. Okay, so this is the normal ratio method. Now let us simplify the formula. Here in this formula, Nx is common. Okay, each rainfall value is multiplied with Nx upon N1. So Nx is common, N1 and N2 they are changing. So as Nx is common, we can take out this as a common. So we can rewrite this formula as Nx upon N1. Okay. Nx is taken as common. Nx upon small n. Small n is what? Similar to previous formula. This is number of index stations. Nx upon n into bracket. Now P1 upon N1, P2 upon N2, and up to Pn upon Nn. So this is the final formula for the normal ratio method. Nx upon n into bracket P1 upon N1 plus P2 upon N2 plus Pn upon Nn. So note down this formula for normal ratio method, and then we will solve problem on this. प्रॅक्टिकल 12:45 ला असतं. आता 3 जण आत्ता जॉईन झालेत. सुशांत सुतार, अजून कोण आले आता? दीपाली पाटील, कांबळे रितेश. इतक्या उशिरा का आलाय तुम्ही? बोला सुशांत सुतार, बोला तुम्ही पहिल्यांदा. सुशांत.
सर,
एवढ्या उशिरा का जॉईन झालाय?
सर मी T1 मध्ये येतलाय. मी काल आजारी होतो म्हणून जॉईन व्हायला नव्हतो, म्हणून आज ह्याला जॉईन झालोय.
आणि तिकडं ऍबसेंट पडणार किंवा?
नाही सर, तिथलं झालंय.
झालंय, ओके. रितेश कांबळे, तुझं काय?
येस सर.
हा, तुझं काय प्रॉब्लेम आहे? तू काय आला उशिरा एवढ्या? दीपाली पाटील, explain why you are late. Okay, take down next problem on this second method, normal ratio method. Note down this problem. A precipitation station X was inoperative for some time, during which a storm occurred. The storm totals at 3 stations A, B and C surrounding X were respectively 6.6, 4.8 and 3.7 centimeter. The normal annual precipitation amounts at station X, A, B and C are respectively 65.6, 72.6, 51.8 and 38.2 centimeter. Estimate the storm precipitation for station X. So here see what data is given. See the first line, a precipitation at station X. So here what we have to find? We have to find Px. And for that, what data is given? The storm totals at 3 stations A, B, C. Okay. Were respectively 6.6, 4.8, 3.7. Now anyone please tell me which type of data is available here. Okay, which type of rainfall data is available here? कसले रेनफॉल व्हॅल्यूज आहेत या? डेली आहेत, annual आहेत का नॉर्मल annual आहेत? 6.6, 4.8 and 3.7. Yes, anyone? उत्कर्ष चौले सांगा तुम्ही. त्या व्हॅल्यूज कसल्या आहेत? डेली रेनफॉल व्हॅल्यूज आहेत का या? कोण सांगेल? चला प्रज्ञा तुम्ही सांगा. कुठल्या टाईपच्या रेनफॉल व्हॅल्यूज आहेत हे मी अंडरलाईन केलेल्या? 3 डेफिनेशन तुम्हाला एक्सप्लेन केलं मी. त्यापैकी कोणत्या टाईपचं आहे?
डेली.
Correct. These are the daily rainfall values. So how we have to write this? We have to write this as PA, PB and PC. So what is PA? 6.6. What is PB? 4.8. What is PC? 3.7. Okay, then see the next line. The normal annual precipitation amounts at station X, A, B, C are respectively. Now the normal annual rainfall values are given. It is clearly mentioned that these are the normal annual rainfall values. So at station X it is 65.6. At station A it is 72.6. At station B it is 51.8. At station C it is 38.2. So these are the normal annual rainfall values. And hence it is asked to estimate the storm precipitation for station X. So this is the required answer. So now we know that here we can use this normal ratio method. Formula for normal ratio method is nx upon n into bracket p1 upon n1 plus p2 upon n2. So let us write the formula. Px is equal to nx upon small n into, now instead of n1 we have to write nx what काय लिहिले पाहिजे सांगा मला कोणी.
P1 upon N1.
आता P1 म्हणायचं नाही आपण PA म्हणायचं.
P.
ओके PA upon NA. Okay, plus PB upon NB plus PC upon NC. Okay, now simply put the values in the formula and work out the required answer. What is value of small n here?
3.
Correct, it is 3. There are 3 index stations. Total there are 4 stations. See, this is X. Okay, and surrounding that there are 3 stations. A, B and C. So value of index station is 3. Hence calculate PX, missing precipitation at station X.
6.13 centimeter.
It is 6.13
centimeter.
So this is normal ratio method. So what you have to keep in mind, in normal ratio method, daily precipitation value is multiplied with the normal ratio. Normal ratio is the ratio of what? Normal precipitation value, normal annual precipitation value at station X to normal precipitation value at index station. That is normal ratio. And when to use this method? When the difference between normal annual rainfall value at missing data station and index station is more than 10%. In that case, we have to use this normal ratio method. Okay, so after the normal ratio method, next method is inverse distance method. Okay, it is also known as US weather method. Okay, inverse distance or US weather method. So this method is more accurate method as compared to previous 2 methods. And see, this is the formula to find out the precipitation at missing station in this method. And the formula is Px is equal to summation of Pi into Wi, where value of I varies from 1 to n, divided by summation of Wi. So here Pi is what? It is a summation of Pi is what? It is a summation of precipitation at index stations. Meaning of small I is index station. And n is what? N is number of index stations. And there is a term Wi. Wi is what? It is a weightage. Every rainfall value at a rain gauge station is weighted, and that weightage is calculated as Wi. And that's why formula is summation of Pi into Wi upon summation of Wi. Now, in previous method, how weightage was calculated? Weightage was calculated as Nx upon Na, Nx upon Nv, that was the weightage. In the similar way, here this Wi is worked out with the formula 1 upon di square. Okay, where di is what? It is the distance between the missing data stations and that index station. Di is what? Distance between missing data stations and index stations. And that is calculated as 1 upon xi square plus yi square. What is xi and yi? Xi and yi, they are the coordinates of the index station. Okay, index station may be any station, say A, B, C, D, likewise. So what is coordinate of that index station with respect to the missing data station? So that is x and y coordinate. And from this x and y coordinate, what we get? We get di. What is di? Distance between the index station and missing data station. Okay, so all of you note down these formula and notations used in the formula. Okay, again I will explain in detail about this formula in the next slide with some reference figure. So at present you keep in mind that in this method formula is Px is equal to summation of Pi into Wi upon summation of Wi, and Wi is equal to what? 1 upon di square is equal to 1 upon xi square plus 1 upon yi square. So in this formula, Px is missing precipitation at station X, Pi is precipitation at any index station or each index station, Wi is weightage at each index station, and di is what? Distance between index station and missing data station. And xi and yi, these are the coordinates of each index station, and for that it is assumed as the missing data station is taken as origin, and with respect to that all index stations are plotted and their coordinates are worked out, and these coordinates are nothing but xi and yi, and from these coordinates we get di, that is distance between index station and missing data station. So immediately note down this. Okay, now let us know more about this calculation of weightage, which is multiplied to each daily rainfall data. Okay, so this weightage is denoted by Wi, and it is worked out with the formula 1 upon di square. So you know what is di? Di is the distance between missing rainfall data station and what? Index station. And that can be calculated. Di can be calculated from these two coordinates, x and y coordinate of that index station with respect to the missing data station. So consider this figure. Okay, let us assume that these are the 4 stations. Okay, let us say station X, station A, station B, station C, and station D. Assume that for station A, B, C, and D, which are the index stations, the data is available, daily rainfall data is available, and for station X, data is missing. Now to find out this data by inverse distance method or US weather method, what we have to do, we have to consider missing data station, that is station X, as origin. So let us consider reference axis through origin. Okay, these are the reference axis through origin. Origin is missing data station. And now what we have to calculate? We have to find out the DI. What is DI? That is distance between the missing data station and index station. Let us consider station A. Now the distance between station A and X is this particular distance, and this is what? This is DA in this case. Okay, DA. Okay, so how to find DA? Find out DA from coordinates of A. Which are the coordinates of A? XA and YA. How to get XA and YA? See, this vertical distance is what? This is YA. And this horizontal distance along this line, horizontal line, is what? It is XA. So if we plot all these stations with respect to this station X, then we can find out coordinate for each station. Similarly, we can find out for B as XB and YB. Similarly, for station C, XC and YC. And for D, it is XD and YD. Okay, now when we have to calculate WI for each station, then how we have to calculate? So WI here is equal to what? 1 upon DI square. Okay, so here instead of WI, we can say as WA. So WA is equal to what? 1 upon DA square. And 1 upon DA square is equal to what? 1 upon XA square plus YA square. Okay, similarly, 1 upon DB square is equal to what? 1 upon XB square plus XA square plus XB square, meaning is same. No, this will be XB and YB. Okay, 1 upon DC square. Similarly, it is 1 upon xc square plus yc square and 1 upon dd 1 upon x d square plus yd square. So what we get from this calculation, we get weightage for each index station, WA, WB, WC and WD. Okay, and then we can write the final formula Px is equal to summation of Pi into Wi upon summation of Wi. This is the final formula for this inverse distance method. I hope it is clear to you how to calculate Wi. So all of you again note down this, how to get the weightages for each index station. Draw the sketch and note down WA, WB, WC, WD and then write this final formula or maybe in this format. Px is equal to Pa into Wa plus Pb into Wb plus Pc into Wc plus Pd into Wd upon summation of W, that is addition of Wa, Wb, Wc and Wd. So immediately note down this and we will solve one problem on this. Okay, now note down this problem. This is on inverse distance method. In a river basin, station A was inoperative during a storm, while station B, C, D and E surrounding A were in operation, registering 74 mm, 88 mm, 71 mm and 80 mm of precipitation. So daily rainfall values are given 74, 88, 71 and 80 respectively at B, C, D and E, and data at A is missing, and for that the coordinates of station B, C, D and E are given as 9, 6, 12 minus 9, minus 11, minus 6, minus 7, 7 respectively, with coordinate of A as 0, 0. estimate the missing storm precipitation of station A by inverse distance method. So all of you note down this problem. So once again, I will repeat this. In this problem, we have to calculate PA. As we have to calculate PA, for that what is given? PB, PC, PD, PE, these daily rainfall values are given. We know the formula is PA is equal to summation of PI into WI upon summation of WI. So that's why here it is necessary to calculate the value of WB, WC, WD and WB. And we know how to calculate WI, that is given by 1 upon DI square is equal to 1 upon XI square plus YI square. So WB is equal to what? It is 1 upon dB square. And how to calculate dB? From the coordinates, that is 9 and 6. These are the coordinates, X and Y coordinate of station B, which are now they are recognized as XB and YB coordinates. And XB is 9, YB is 6. So it is 9 square plus 6 square. 1 upon 9 square plus 6 square is W. Likewise, you have to calculate the values of WC, WD, WE. When you get all these weightage values, then you have to multiply each daily rainfall record with this weightage. Okay, and then you have to divide this with summation of W, that is WB plus WC plus WD plus WE. Then you get the final answer for PA. Okay, so now you solve this and tell me what is the value of PA. हे समजलं का तुम्हाला?
Yes, sir.
Okay.
Sir, 77.51 mm.
Okay, so this is a solved problem from one book, and your calculated answer is correct. It is 77.5. Okay, so with this, today I will stop here. See what we have covered today. So we have covered the first part of assignment number 1, estimation of missing precipitation data. There are three methods: arithmetic mean method, normal ratio method, inverse distance method, or US weather method. In the next practical turn, we will learn how to find out average precipitation over area. So there are again three methods: arithmetic average method, Thiessen's polygon method, and iso-IT method. And if possible, I will also cover this second assignment, that is the consistency of precipitation data. So for next practical, you please ready with the graph paper, as we have to draw a graph for this second assignment for checking consistency of precipitation data. For that, we have to prepare a double mass curve of a rainfall. So be ready with the graph paper for next practical. Okay, so today let us stop here. Thank you very much.
सर
हा बोला.
असाइनमेंट 1 मध्ये फक्त प्रॉब्लेम्सच लिहायचे ना?
नाही, तुम्हाला मी अजून त्याच्यामध्ये काही पॉइंट्स असतील ते देतो.
हा.
जरा सिलेबस होऊ दे. हा, आता
हा
काही
हा.
लिहू नका तुम्ही.
ओके सर.
हा, मग मी ते पहिला चॅप्टर थोडा झाला की मी तुम्हाला सांगेन की असाइनमेंट नंबर 1 मध्ये कोणकोणते पॉइंट्स लिहायचे. ते थेरी क्वेश्चन्स पण त्याच्यामध्ये लिहायचे. ओके, अजून काही कोणाला विचारायचं आहे का? बोला. If you have any question, हा बोला.